was I screenshot just random questions that I thought were the most important because I made the quizzes, so I know that these are the most important ones. For you to be familiar with how to answer. This is from your web assign. Somebody freaked out this morning. Wait, but web assign it's not due till Wednesday. Okay, fine. If these are your questions, then you're lucky. There you go. If they're not your questions, you have the same types of questions. It's just different numbers. So as we go through, I broke it into 8.5 and 8.6. It's important, very important, that you guys are familiar with what these questions are asking. I told you that's multiple choice. So if you have questions like this first one here, this one here, this one here, all right. If they give you choices like you're making a school schedule, if they give you a package deal, like you can pick 4 of these, 3 of these, 2 of these. If you have a menu where you can pick 1 appetizer, 3 different entrees, 2 desserts, something like that. All that is the basic fundamental counting principle question where you're just multiplying whatever the choices are that they gave you. So like in this first one, you can have 4 different amplifiers, 2 CD players, and 8 speaker modes. All you do is take all of the different category, however many choices are in each, and you multiply them together. So that's where we got 4 times 2 is 8. 8 times 8 is 64. That's how they got 64 different ways. But do you guys see the type of question I'm talking about? Like here, when you are preparing your school schedule, they give you different categories, and you can pick a certain amount of things from each category. You have 3 math courses you can take, 4 sciences, and 3 humanities. You just multiply those together. 3 times 4 is 12, times 3 is 36. That's how they got those 2 answers. Questions about that? No questions. All right. The math behind this stuff is not hard. It's just understanding what they're asking. In the second question, they're saying how many ways can a 13-question true or false exam be answered? Assuming you don't skip any questions. They are telling you different parameters. How many questions are on this test? 13. So there's 13. Look, there's 13 answers that you have to give. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For each question, think if you're sitting there and you're taking a test, how many possibilities of answers do you have if it's a true false? You have 2. So for the first question, I have 2 different possibilities. For the second question, I have 2 different possibilities. For the third, all the way down, correct? You guys with me?
Yes.
So what do I do to all these numbers? We're going to multiply. This is the same as saying 2 to the 13th power. Okay, you guys, a lot of you, some of you may have been able to think of it that way, but a lot of you would have said, oh, there's 13 questions times 2 choices, so 13 times 2 is 26. It's not 13 questions and just 2 choices. It's 13 questions that each have 2 choices. So it's 2 times 2 times 2 times 2. You have to think of it that way. A lot of times this question is asked with a like a test type situation. Like if I said to you, you have a 5-question multiple choice test with 4 answer choices per question. Some of you would go, oh, 5 times 4 is 20. That's not the case. How many questions do you have in this new scenario I gave you?
5.
So I have 5 spaces. And for each space, how many possibilities do I have?
4.
So it's 4, 4, 4, 4, 4. So it's not 5 times 4. This case would be 4 to the 5th power. However many answer choices you have per question raised to the however many questions you have. Do you guys see the difference in those 2 type of questions? Like how it's being asked? If you don't, stop me and tell me. No difference? Okay. All right, here we go. We can't do the next one because it says to refer to number 4, which I didn't realize that, and I don't have a number 4. So, when we are talking about, and I told you guys, there's going to be like license plates, ATM codes, stuff like that. It's always going to be the same kind of setup, just different kind of parameters. If they say to you in a certain... Yeah.
Could I see what difference you mentioned? I'm just trying to remember.
Yeah.
Or keep track to see if it... Okay, so this is how you guys should think through these problems. Read the question. It says a standard license plate consists of 3 letters and 4 digits. So look, write out 3 letters and then 4 digits. 1, 2, 3, 4. There's going to be some stuff that you need to know. You need to know how many letters in the alphabet. You need to know how many digits there are, 0 through 9, that sort of thing. But what do they tell me? Do they tell me anything specific, like the letters cannot repeat, numbers cannot repeat, anything like that? Do they give me any parameters that I have to follow?
No.
Nope. They just say the first 3 things are letters, the last 4 are digits, correct?
Yeah.
So how many letters are in the English alphabet?
26.
All right, so there's 26 possibilities for this first space. How many are left? Or how many can I use for the second one?
26.
26. How many for the third one?
26.
26. The reason it's 26 all the way is because they don't tell me that it can't repeat. I could have AAA, BBB. If they said they cannot repeat, then the number would change. I'll talk to you about that in a second. But then what are the options for digits? How many digits are there? 0 through 9. How many digits is that?
10.
It's 10 digits. It's not 9, guys. It's 10. If you count them, 1 through 9 is 9, and then 0 is 10. So I have 10 here, 10 here, 10 here, 10 here. And then when I multiply them all together, I get this ginormous number right there. If the question said, same exact question, but I'm going to change a little bit. Same question. Letters and digits cannot repeat. All right? Same exact question. It's going to be 3 letters and 4 digits. Letters cannot repeat. Digits cannot repeat. Does everybody understand what I mean by that?
Yeah.
Okay. So in the first column, there's 26 letters. How many possibilities do I have here? It could be any of those 26. But whatever that letter is that's there, it cannot be repeated. So then how many letter options do I have left?
25.
25. So then now how many letter options do I have?
24.
24. Do you guys see that? Yes or no? Talk to me.
Yeah, I see it.
Okay. So for digits, there's 10 to begin with, but I can't repeat them. So then how many are left to choose from?
9.
9, then what?
8.
Then what?
7.
And then you would multiply that together. But do you guys see the difference? You have to look to see if they give you some sort of stipulation that, oh, I cannot use this again, or I can repeat, that sort of thing. We okay with that?
Yeah, I see it.
Okay. Stop me if you don't. All right, look at the next one. A personal identification, a PIN number. All right. The first thing says there's it's a 4-digit sequence. So what are the total possibilities? Well, how many digits, guys, are we talking about? It's always 0 through 9. So how many digits is that?
10.
10. So I can have 10 different things here, 10 here, 10 here, 10 here. Does it tell me that the numbers can't repeat? No. Does it tell me that that one of them has to be a certain number or something like that? No.
No.
So then that's it. That's where we got the 10,000 from.
Yeah, because if it said it couldn't repeat, then you would have to do the...
10, 9, 8, 7. Yep. Good. Like here.
Right, so then, wait for each... Oh, so then it would be like 10 factorial. Is that...
Correct. Well, it would only go 10, 9, 8, 7 because it's only 4. spaces. But yes, 10 factorial would be 10, 9, 8, 7.
Oh, right. So it would cut off the factorial at the.
Uh-huh.
All right, then.
But that's a good way to think of it.
At the first 4, right?
Yep. So like in this case, they're telling me that it's a possibility of, what's the possibility? When I can have a digit here, a digit here, a digit here, but what did they tell me about the last one?
It can't be a 0.
It can't be 0. So the first one can be 0 through 9, doesn't matter. The second one can be 0 through 9, doesn't matter. The third one can be 0 through 9, doesn't matter. The fourth one can be
1 through 9.
1 through 9. It can't be 0, so there's only 9 choices there. That's where they got 9,000. You guys see that?
Yeah.
Sean, you see that difference?
Yes.
Okay. Everybody with me? It's just paying attention to
So
words.
Instead, it would be 9 times 9 times 9 times 9
For which part?
for the second one.
No, it's 10 times 9, 10 times 10 times 10 times 9. The only stipulation they gave me was the last digit.
Oh, the last one. Okay,
Yeah.
right. Sorry.
If it was, they could
I was
only be, nothing could be a 0, then you're right. It would be 9 times 9 times 9 times 9.
Right. Sorry, I misread
Yeah,
that.
no, it's okay. Pay attention to what you're reading. All right, here, this one. Everybody will have a problem like this. It's a basic permutation problem. You guys have the formula in your notes. It looks exactly like combination. It's just one less step. It's n factorial over n minus r factorial. N is the first number, r is the second one. So it's 19 factorial over 19 minus 2 factorial. 19 factorial over 17 factorial. 19 times 18 times 17. I'm going to stop there. Why am I stopping there?
Because you can cancel them out.
You just cancel them out. And then 19 times 18 equals 342. So that's a basic, super easy one. All right, and these next few questions, you have to pay attention to the wording. I told you guys before, when you're lining up in a line, order matters. Somebody has to be first, somebody second, somebody third. When you're sitting down in a row of a movie theater, something like that, someone has to sit in the first seat, someone has to sit in the second seat, someone has to sit in the third seat, something like that. So how many ways can 6 children pose in a photograph for a line? Well, how many spaces are there in the picture?
6 spaces.
6 spaces. So 1, 2, 3, 4, 5, 6. All right. So how many possibilities are there for the first person to get in line?
6.
There's 6. Once that first person is in line, they're standing there. How many people are left over that can get in the second spot?
5.
5. So now the first 2 people are in their position. How many are left over for the next one?
4.
Then what?
3.
Then what?
2.
Then?
1.
Yep. So you're just multiplying everything together. That's where we got 720. Does that make sense?
Yes.
Okay. Same question as the next one. There's 8 people to sit in an 8-passenger vehicle. How many seats are there in this vehicle?
8.
So 1, 2, 3, 4, 5, 6, 7, 8. First person gets to pick. They have the choice of how many different seats?
8.
8. Now that person's sitting down. So the next person that goes to choose, how many seats are left?
7.
Then what?
6.
Then
5. 4. 3. 2.
that's where we got the 40,320. All right, that
So yeah, 8 factorial. Basically.
correct. Now this question could be changed if they said, okay, there's 8 people in a 4-passenger vehicle. All right, how many spots are there in this car?
4.
4. So there's 4 spots. So how many choices, how many possibilities are there for the first seat to get filled up?
8.
There's 8. All right, so that person sits down. Now, how many people are left over?
So this is 7, 6, 5, and then that.
7, 6, 5. Now look, the car is full. So what happens to 4, 3, 2, and 1?
They don't get a spot.
They don't get to go. But do you see how the question could be changed? By the total number of people available versus how many people can sit in the row, can line up for the picture, can sit in a car, something like that.
Yeah, I see it.
Okay. 9 justices in the Supreme Court. Now again, having this guys in front of you with this stuff worked out will help you on your quiz. Having me talking to you in the background, not going to help you on your quiz. But if there's 9 justices that are getting in a picture, everybody's in the picture, right? As you read through.
Mm-hmm.
So like, hey, line up. All right, well, there's 9 spaces available. Then that first person gets in the picture. How many spaces are left?
There's 8.
8. Then what?
7.
6, 5, 4, 3, 2, 1. You multiply that all together, and that's where we get the 362,880. Now again, the way that you could change that, there's 9 people lined up, but only 5 get to be in the picture. So if there's 9 people, but 5 in the picture, right? How many spots are there that we have to fill?
5 spaces.
5 spots. So 1, 2, 3, 4, 5. Well, how many possibilities are there for that first spot? 9.
9.
All right, that first spot is filled. How many people are left over now? 8,
8.
7,
7,
6,
6,
5. And then what happens to 4, 3, 2, and 1?
They don't get in the picture.
They don't get to go in the picture. Make sense?
Yes.
You guys got to think a little bit. All right, this is the last question for here, and then we'll move on to 8.6. This is a different kind of a question because it says distinguishable. I told you guys, when you see the word distinguishable, you should remember divide, and then I put an exclamation point behind it. Divide factorial. Because the way that we do this, it's the total factorial over repeated factorial. Meaning, how many letters do they give us? How many total letters are there?
9 letters.
9 letters. So it's 9 factorial over. Do you see any letters that repeat?
Yeah, the C's and R's.
Okay. So how many times does the C repeat?
5 times.
So it's 5 factorial. You gotta have the factorial with it. And then how many times do the R's repeat?
4 times.
4. So when we work this out, it's 9 times 8 times 7 times 6 times 5. I'm going to stop there. Then I have 5 factorial, 4, 3, 2, and 1. My 5 factorials cancel out. Now then I like to cross cancel inside. You can multiply 9, 8, 7, 6 and then divide it by 4, 3, 2, 1, which is fine. I just like to say, okay, 4 goes into 4 once, 4 goes into 8 twice, 3 goes into 3 once, 3 goes into 9 3 times, 2 goes into 2 once, and 2 goes into 6 3 times. So now we can just multiply. So 3 times 2 is 6, times 7 is 42, right? 42 and 3, what is that, 126?
Yeah, 126.
126 ways. When they say distinguishable permutation, they're going to give you a bunch of letters. It's the total number of letters, factorial, divided by however many letters repeat, like that. Questions?
No.
Okay. All right. That's 8.5. Now let's go to 8.6. Yep.
Miss Meadows, are you gonna post this on Canvas?
I'm going to post it on YouTube. I'm not posting all this worked out. You guys should be doing that as we go along. Aren't you?
Okay.
Isn't that what you're doing?
Yeah, of course I am.
Of course.
Of course.
Of course.
All right, thank you.
Of course.
Anything to help. Okay, if you go under modules, guys, I put this in modules. Chapter 8, it says deck of cards. Should be very easy for you to find. A lot of us aren't familiar with cards. I think this is a good thing to have in front of you, especially when we get to one of the last questions at the bottom. So let's look here.
I played Texas Hold'em for a very, very considerable amount of time as a good thing with my grandparents. So
There you go.
I'm pretty uncomfortably familiar with the deck of cards.
You're good to go then. That's good. All right, so I had some people last period that did not know anything about deck of cards. You know what? That's fine. That's totally fine. But remember, probability in its basic essence is what you want over the total. What we need to remember with probability is the word and means to multiply, and the word or means to add. Two very important things to remember. So I want to find the probability of selecting a black card from a deck of cards. Well, there's 52 cards total. If you don't know how many of them are black, you literally can just count. Half the deck is black if you don't know that. But look, it's right there for you. So 26 out of 52. I told you probability can be written as a fraction, a decimal, or as a percent. So you just have to match your answer to whatever the answer choices are. But 26 out of 52 can reduce to 1/2 or 50%. All right, second question. It's want over total. You want a 2 out of or a 10 through a 10 out of the total. Well, how many total cards are in a deck? We just said 52. How many of them have a 2, 3, 4, 5, 6, 7, 8, 9, or 10 on them? Count. Look up here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 spades. That means, 9 clubs. That means there's 9 spades. There's 9 in this row. 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 What's 9 times 4?
36.
36. And then you can divide both of these by 4 and you get 9 out of 13. But I think that's a real good visual for you guys to have for yourselves. Everybody okay with that?
Yep.
All right. These questions tend to be a little easier for us because, I don't know, it just makes more sense, I guess. But remember, probability is what you want over the total. Now, last period, I asked this question. It took them like 2 or 3 minutes to answer, and it was because they didn't read. I said, well, how many total people are in this graph? And they just were all like, Guys, if you read the question, it says one of a team's how many season ticket holders?
2,200.
2,200. If you didn't read that question, what could you do with all of the numbers that are on the graph?
Add them.
You could add them. But they want, what do we want? We want the winner that's older than 39 years. So go to your chart. Would you agree with me that we're talking about this population and this population?
Yes.
Okay, so what do I do with those two numbers?
You add them.
I'm going to add them. So it's 836 plus 506, which gives me what?
1,342.
1342 divided by 2,200. Now, some of you in your calculator will go 1342 divided by 2,200. And I got 0.61, right? But if all of your answers were in fractions, you need to understand that 0.61 is 61 out of 100. If all of your answers were in percentage, you need to understand that 61 out of 100 or 0.61 is 61%. You got that?
Mm-hmm.
Okay. So you'll have a question like that. You'll have a couple card questions, and you'll definitely have some marble questions. Go ahead and...
So then, do we have to change it to a percent, or can we just keep it?
Nah, you can just keep it however you want. Just pick your answer choice. Go ahead and cross off this marble one that says that the marbles are different colors. I stayed pretty basic with the marble questions. I didn't want you guys to get too overwhelmed with anything. But, and again, I know that I left the answers here just so you guys could see it. But when we have a probability question with marbles, the biggest thing, guys, right here, without replacement. What does that mean?
Did you put the marble back in the bag, or did you leave it out?
Left it out.
So now you only have one less of
Correct.
the original amount.
Now, pay attention, because on your quiz, I'm almost positive I did one that was with replacement and one that was without. And I guarantee you your answer choices will reflect if you do the scenario both ways. So what we need to do here is we need to think about what this question says. Probability of both of them being red. That means I reach in, I grab a red marble, or I reach in again and get a marble, and I reach in again and get a red marble. And. It doesn't say it, but it is inferred. So it's red and red. What does red mean to, what does and mean to do?
To multiply.
Multiply, okay? It's really important. So now we just say, okay, how many total marbles are in this bag? I have 1 green, 2 yellow, 4 red. So how many is that?
7.
7. How many of them are red?
4.
4, okay? And we said was to multiply. So guys, I'm going to assume that I took, the marble that I took out was red. Did I put it back in?
No.
No. So how many are left in the bag?
6.
6. And how many of those are red?
3.
3. We're going to assume we got what we wanted. So I multiply, I have 12 out of 42. And when I simplify, I get 2 out of 7. Does that make sense? Yes or no? Okay. The next one is the probability that I reach in the bag twice again, but that the first one is not yellow and the second one is not yellow. Do you see how it says neither? Actually, neither marble is yellow. So I reach in. Yeah. Okay, so how many marbles are in the bag?
10 marbles.
10 marbles. What is the probability, guys? How many are not yellow?
6.
6 out of 10. Does everybody see that? So we're going to assume I reached in the bag and I got a non-yellow marble. And I reach in again. So how many are left in the bag?
9.
9. And how many of them are not yellow?
5.
Mm-hmm. So 30 out of 90, which gave me the 1/3. Questions?
No.
We okay?
Mhm.
All right, here is a question where this I think is so unbelievably important that you guys have your deck of cards. Where'd my deck of cards go? Right there. I think a lot of us are very visual, and I think this is a really good thing to do, especially if you're not familiar with the deck of cards. So this question is saying the probability, let's write out what it's saying. It's saying probability that the card is a face card. What's that word say? Or a black card. Everybody agree with me?
Mhm.
Now, before you start to think, is this mutually exclusive or overlapping, blah, 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 don't freak out about that. Let's just do each piece at a time. Let's do face cards. First of all, it's want over total. So there's 52 cards in a deck. Guys, highlight. How many cards in this deck have a face on them?
12.
12. Does everybody see that?
Mm-hmm.
What does the word or mean to do?
To add.
Add. And now I'm looking at this same deck. And I want the probability that I get a black card. So here's all the black ones. How many of these cards are black in the whole deck?
26.
26 out of 52. What do you notice about where I colored?
They overlap.
Do you guys see how this portion right here overlaps? There are cards in a deck that have faces on them that are also black. When you have an overlapping event, you have to subtract the overlaps. So how many of these cards are overlapping? 6 out of the 52.
6.
So 12 plus 6 minus 6 is how much? 36.
It would be 36.
So 36 out of 52, and that reduces to 8 over 13. But I think it's really important that you guys have this in front of you so you can see if they overlap or if they're mutually exclusive. I mean, if I had the same question and I said, okay, what's the probability of a diamond? No. I'm going to say probability of a 2 or a face card. Okay. So probability of a 2. Here's my 2s. How many 2s are in a deck?
4.
4 out of 52, right? What does the word or mean to do? Add, all right. And then how many face cards? Here's my face cards. How many face cards do I have?
12.
12 out of 52. Look at these two things that I'm talking about. Are there any cards in a deck that are 2s and also have a face on them?
No.
No. So this is not an overlapping event. This is a mutually exclusive event. Divide by 4, you get 4 out of 13. This is a mutually exclusive event. One has nothing to do with the other. But I think it's really good if you guys have this visual in front of you so you don't make mistakes on that question.
I'm sorry, but I love this. This is funny to me.
3 cards. Whoa. All right, last bit I want to talk about. The last question, this last little bit is a little wordy, so I want to make sure you guys are on top of that. But a question like this, I don't anticipate anyone having an issue with. In a table, blah, 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 blah. Whatever you need is on the table. Remember, probability is want over total. So I want younger than 30 over the total. Guys, how would I figure out how many total students we're talking about?
Can I add them up?
I could add them, right? So 12, 17, and 7 is what? 12, 17, and 7. 36?
So that's 36.
All right, 36 kids.
Yeah, 36.
And I want, or students, whatever we're talking about. I want younger than 30. So would you guys agree with me that this age group is younger than 30? This one's younger than 30. Or 31, sorry. And this one's younger than 31, correct?
Yes.
So I have 12, 17, and 3. What does that give me?
32.
So 32 out of 36. Divide by 8. Nope, just kidding. Divide by 4. I'm going to get the answer 8. Divide by 4, and I get 8 out of 9. If they said, what's the probability of getting 31 or older, what would your fraction look like?
That'll be 4 over 36.
4 out of 36. All right, this question can be a little difficult, but once I explain it, I think you guys will be okay. The first question is asking for a specific number. The second question is just asking for probability. So like last period when I did this, you're like, well, isn't probability want over total? It absolutely is. What you want over the total. They're not asking you for just want over total in the first question. They're asking you for a specific number. So if we followed the want over total, all right, do I know specific numbers here or do I just know percentages? Did they tell me that this is a specific number of people are unemployed?
No.
No, they just told me percentages.
It's good.
So I'm going to estimate the number of unemployed for a certain age group. So let's think about this.
They want to know what, 16 to 19? What's the percentage of people that are unemployed in that age group?
16%.
16%. Well, what's the total percentage of anything? What's the highest you can get without getting bonus points?
100.
100. So this question is, they're not asking, they want to know an actual number. I know that 16% is unemployed. So we're going to set up a little proportion. How many total people are we talking about?
9.99 million.
Would you guys agree with me that 9.99 million is 100% of the population?
Yes.
Okay, so all we're doing here is setting up a proportion. I want to know what percent is that. Did I set that up correctly? Okay, so when I multiply, I get 100x equals, what's 9.99 times 9.99 times?
159.
So 159.84. Then to get x, I divide both sides by 100, so I get 1.5984. So that's where they got the answer of 160 million people. But do you see that question asked you to go a little bit further? They didn't ask for the percentage or the probability. They asked for the actual number. So I took the probability from the information they gave me, and then I could figure out what percentage 16% was of 9.99. That make sense?
Yeah.
Okay. The rest of them are literally exactly what it says. What's the probability that a person is 25 to 44? Well, what's the percentage of 25 to 44 unemployed? 36%?
36%.
Okay. Out of a total of 100% population. Well, if I divide both of these by 4, I get 9 out of 25. That's where that came from. What's the probability? The want over the total. So what do you want? You want the number of people 45 to 64 that are unemployed. That's 26%. Out of the total percentage that we're talking about is 100. Well, divide that by 2. I get 13 over 50. Right?
Yep.
And then what's the possibility or probability that they are 45 or older? Well, 45 or older, that's 26%, right? Plus that 5% over a total, so 31 out of 100, which is what you got right there. So do you see how those two questions are asked differently?
Yeah.
All right? Okay. All right, last thing. I wanted to talk you guys through this. When we talk about probability or likelihood, it's the chance of something happening. So if you're given a question and it says the probability of something happening is 42%, what's the likelihood of it happening? It's whatever they gave you. It's 42%. It's 42 out of 100, which is 21 over 50. If they ask you a question and they say, what's the likelihood of something happening? The probability of it happening is 2/5. So what's the likelihood that it's going to happen? And then your answer choices are all in decimals. You would just say 2 divided by 5 be 40.4. Or if they were all in fractions, it would be 40%. You guys see that?
Yep.
Okay. The one that can be a little tricky, and it's not after I go through this, is if they give you a question, and you'll have one of these on your quiz, and it says, what's the probability of something not happening? Or what's the likelihood of it not happening? If I tell you that the probability of an event or the likelihood is 1/3 of it happening, well, what's the likelihood that it doesn't happen? If you got a 1/3 chance that it does happen, what's the chances that it doesn't happen?
2/3.
2/3. Because percentage, probability, likelihood, it's all out of 100. One whole. So if I tell you that the likelihood of something happening, you got a 26% chance that you're going to get into Harvard. Well, what's the chances you're not going to get in?
would be 74%.
74%. Do you see where that came from? You guys with me?
Yeah.
All right, same thing if I said, okay, the likelihood of something happening is 0.63. What's the likelihood or probability of it not happening?
0.37.
0.37. Correct.